This is a short video that shows you some methods of doing long division. This video just focuses on numbers up to 3 digits, but you can use the methods here to work with longer numbers. So what is division? Well, when you do division, what you're saying is, how many times can I take one number away from another, and will there be anything left? So division is just repeated subtraction, and you can solve a division sum in this way. Let's take the example 46 divided by 6. Now we're going to do a subtraction sum, and we're going to see how many times we can take 6 away. So if you do that sum, it looks like this. 46 minus 6 equals 40, minus 6 equals 34, and so on until we get to a final answer of 4, and we can't take 6 away again. So when you've got to that point, you count how many times you've managed to take 6 away. 1, 2, 3, 4, 5, 6, and 7. So we've taken 6 away 7 times. So 46 divided by 6 is 7 with 4 remaining. Now I've done this as repeated subtraction. You can also do repeated addition. So we could have started at 0 and added 6 until we went over 46 and then found out how many times we had to do it. So you can go either way depending on which you prefer. However, repeated subtraction or repeated addition gets more complicated with bigger numbers. In this case, we need a different method. So what I'm going to show you on the following slides is a different method of doing it. However, I will at times use repeated addition or repeated subtraction to handle some of the smaller sums I'm going to do. Now if we had this sort of sum, 576 divided by 18, if I tried to use the repeated subtraction method or repeated addition to do this sum, it would get very complicated, it would take a long time, and it would be prone to mistakes. So we're going to look at a different method. And to explain this method, I'm going to introduce 2 new words. One is dividend, and this is the big number that you're dividing. The other word is divisor, and that's the number you're dividing by. So we're going to use the bus stop method to do this sum first of all. Now we look at this first of all as 5 divided by 18. Well, we can't do that because 5 is smaller than 18. So instead we're going to look at those first 2 numbers together. So we're going to look at 57 divided by 18. Now I prefer to use repeated addition to do these smaller sums. So I'm going to think of 18 and how many times can I add it. So if I count in 18s, it's 18, 36, add another 18 is 54. And if I try to add another one, I would go over the 57 that I'm aiming for. So I've added 18 3 times. So 57 divided by 18 is 3. What I need to do now is do a small multiplication sum. So I need to take my divisor 18 and multiply it by the answer I've just got. 18 times 3, and it's 54. And I write that answer underneath the 57. Then I do a subtraction sum. I do 57 minus 54, and that gives me 3. My next step is to take that 6 that I'm left with on the end and move that down to where the 3 is, and that number there, 36, becomes my new dividend. So now I'm doing the sum 36 divided by 18. Again, I can do that as repeated subtraction or repeated addition. I prefer to count up in 18s, so 18, add another 18 is 36. So 36 divided by 18 is 2. So my answer to that bigger sum, 576 divided by 18, is 32. Now long division can be quite complicated, so I'm going to do a couple more examples. Let's do this one, 645 divided by 15. And again, I've got my dividend and I've got my divisor. I set it out in the bus stop method. Again, that first number 6 divided by 15 I can't do, so I put in a 0 there, and instead I look at those first two numbers together, 64. So 64 divided by 15. Again, I'm going to count up in 15, so 15, 30, 45, 60. Again, if I add another 15, I'm going to go over 64. So I'm going to stop there, and I've added 15 4 times. So 64 divided by 15 is 4. Now I do my multiplication sum. So I multiply my divisor by that answer of 4. 15 times 4 is 60, and I write it underneath the 64 that I've got there. Then I do my subtraction sum, 64 minus 60, and that gives me an answer of 4. My next step is to move that 5 down to where the 4 is, and that number now, 45, becomes my new dividend. So I do 45 divided by 15. Again, I can count up in 15s, 15, 30, 45. I've added 15 3 times, or if you wanted to do it as subtraction, you would take 15 away 3 times, and that gives me that answer there. So 645 divided by 15 is 43. I'm going to show you one more example that has a remainder. So 752 divided by 21. Again, that's my dividend, that's my divisor. We'll set it out using the bus stop method. 7 divided by 21 I can't do, so we put a 0 in there, and we look at those first two numbers together, 75 divided by 21. Well, if I count up in 21s, I get 21, 42, 63. And if I try and add another one, I would go over 75. So there I've added 21 3 times. So 75 divided by 21 is 3. Again, I multiply that answer by my divisor. So 21 times 3 is 63. And I do my subtraction sum, 75 minus 63. And that gives me an answer of 12. Then I move that 2 down, and that gives me a new dividend of 122, which I then have to divide by 21. So again, I can count up in 21s, 21, 42, 63, 84, 105. And I can see there that if I add another 21, I'll go over my target number of 122, so I'll stop there. So 122 divided by 21 is 5. I do my multiplication sum, and I turn that into a subtraction. 122 minus 105 is 17, and that gives me my remainder. Now you may have seen, as I've gone through this, a problem with this method of long division. And that's because you sometimes end up with numbers that are still hard to deal with. I'll just explain that a little bit more. So the difficulty with this method. You can still end up working with long numbers, and sometimes it doesn't work at all. For example, if we have a sum like this, 236 divided by 32, well, I can't do 2 divided by 32. So if I look at those first two numbers together, I can't do 23 divided by 32. So I'm left with 236 divided by 32. I can't break it down anymore. If you find a problem like this, there are alternative methods you can use. So this is the alternative method 1, rounding. Now just in the corner up there, I've put the original sum that we're working with just as a reminder of what it was. But what we can do first of all is round the numbers we're working with up or down to get an idea of what the answer will be. So in this case, we're going to round 32 down to 30, and we're going to round 236 up to 240. Now if you're not sure how to do rounding, I do have a video about it on my channel. But that's a sum that we come up with when we round these numbers. So we've got 240 divided by 30. Now you might look at that and think, well, they're still big numbers I'm working with. But the advantage of this is that they both now end in 0, which means that we can ignore those zeros. We can cancel them out, and we now have a sum that is 24 divided by 3, which is much easier to do, and the answer to that is 8. That's not the final answer though, because we're still working with these rounded numbers. It's not going to be our exact answer. So what we need to do now is take the answer to that simplified sum, 8, and do a little bit more with it. So what we're going to do first is multiply this answer of 8 by our original divisor. And as you can see in that reminder sum in the corner, that was 32. So we do 32 times 8, and that gives us 256. Now this is more than 236, which was our original dividend. So we know that that's too much, we've gone too far. So instead we're going to take it down 1, and we're going to try 32 times 7, and that gives us 224. So that's less than our original dividend, so we know that we're on the right lines with this. Now we have to find the difference between this answer and the original dividend. So that was 236, minus 224 is 12. So our answer is, to this sum, 236 divided by 32, our answer is 7, remainder 12. I'm going to show you the alternative method 2, which is common divisors. So to do this, we have to find a number that divides without remainders into both the divisor and dividend. It's easiest if you do this to start with 2 or 3 and keep dividing until you can no longer do so without remainders for at least one of the numbers. At that point, stop. So in this case, we can divide 236 by 2, and that gives us 118. We can divide that by 2 again, and it gives us 59. We can't divide that by 2. We can't divide it by 3. We can't divide it by any number because it's a prime number, so we have to stop there. So we divided it twice. We can do the same now with 32. We have to use the same number, so we do 32 divided by 2, which is 16, divided by 2, which is 8. Now we could keep dividing by 2, but with our 236 we could only divide it by 2 twice, and we had to stop. So in this case, for our divisor 32, we can only divide that twice. We can't do it any more than we did the other number, so we have to stop at 8. So we've now got the sum 59 divided by 8. We can do that as 7, remainder 3. Now this will give you the correct whole number for your answer, but not necessarily the correct remainder. So we have to do something else. At this point, you can use your answer to perform the same multiplication as in the rounding method. So that's when we did our 32 times 7, which was 224. And then you can follow the same process to get your final answer, to get the correct remainder. So you can follow the same process as in the rounding method. Or you can also work out the remainder by performing a reverse calculation. To make our original dividend and divisor smaller, we divided each one by 2 twice, so we need to do the reverse of this with our remainder. So the remainder we had was 3, so we multiply 3 by 2 twice. So 3 times 2 times 2, that gives us 12, and that gives us the correct remainder. Now these methods take practice, they are quite complicated, and you might even find your own method of doing long division, but at least this gives you something to work with, and you can keep practicing and just get your head around the whole thing. I hope it's been useful.